San Diego ship repair. A little bit about BAE. We're a defense contractor who does ship repair for the Navy here in San Diego. We work on all classes of combat ships except submarines, but everything from destroyers to aircraft carriers. A little bit about myself. I was born and raised in Michigan. I attended college at Ferris State University, and I studied welding engineering technology. And you've probably never heard of that. There's 4 colleges in the U.S. that offer that degree. Ferris State is one of those. It's a very hands-on, lab-based training class. We've got a lot of classroom training, but we were able to take that knowledge of welding processes, welding automation, metallurgy, how to make processes more efficient and apply those in actual lab-based training sessions. So we had a huge welding lab. We had 2 robotic welding cells. We had an automated laser welding cell. We had plasma cutting tables. And all of our teachers came from the industry. So we were constantly given lab assignments that recreated things that these teachers have seen from their careers. So we had really great learning experiences at Ferris. They were all hands-on training. I worked at 3 shipyards. Here's pictures of the 3 ones in New Orleans. This one's in Mississippi, and this is here in San Diego. This picture here in the middle, this shipyard was 800 acres. To give you a little perspective of the size, it took me 20 minutes to walk from one fence line to the other fence line. So it's a pretty big, impressive shipyard. And it gives you a little bit of sense of humor of how expensive San Diego is to Mississippi. Because this is my current shipyard. It's 17 acres. A little bit different. So a little bit about my company. As I mentioned, we're 17 acres on San Diego Bay. We are a full-service shipyard. We have a structural shop, a machine shop, pipe shop, rig shop, paint and blast shop. We can do pretty much everything the Navy needs us to do. San Diego Ship Repair also is doing a lot of capital investments. We just finished construction on a brand new 55,000-ton floating dry dock. If you're not familiar with what that is, a dry dock allows us to bring ships out of the water to work on the underwater hull. We can do structural work, paint work. We pull the propellers off, all the main propulsion shafts off, and we can overhaul all those systems. This is actually a picture of our new dry dock, and just to give you a space perspective again, this is a manway right there, which is about 15 by 15. The dry dock is 960 feet wide and 205 feet wide. It's a big dry dock. It's the largest dry dock in California and the 3rd largest dry dock in the United States. We also have a 26,000-ton floating dry dock. We have 4 piers that total 2,000 feet of berthing space, and we can hold 8 ships at one time, including our dry docks. We have 96,000 square feet of production space, and we have roughly 2,000 employees. Ship repair is not what it used to be. It used to be a lot of guys with sledgehammers pounding rivets together is what ship construction used to be. The Navy has come a long ways, and they're a lot more technologically advanced. This is a picture of the USS Zumwalt. This whole deck house is all composite. It's all about weight savings. It's all about making the ships more efficient. That way they can have more room for fuel and more room for fuel and weapons. But it's all about less crew, less weight, more efficiency. And engineering is at the forefront of those processes. So who is BAE Engineering? As I mentioned, I'm a welding engineer. I focus heavily on our welding processes. I do a lot of work with our welding procedures, which is a detailed welding specification that tells the welder exactly how to do his job. So it talks about different welding, or it lists the exact welding process, the filler material, the shielding gas, what preheat and interpass temperature he might have to use, or what post-weld heat treat he'll have to use. But that's all for production. Before we get to production, we have to do a welding procedure qualification, which proves to the Navy that we can weld this certain material together and not have any negative side effects. They have very strict requirements for defects and mechanical properties. So we do a physical mock-up of the procedure and we do tests. This is actually a picture of a procedure we qualified last year. So after the weld is done, we'll send it for x-ray to look at the inside of the weld to see what kind of defects are there, if there's any lack of fusion or porosity. Then we'll do actual destructive testing. We'll cut this pipe up into sections, do tensile tests, and we'll do bend tests to look at the strength and the ductility. So that's one of my main focuses. We also do a lot with process improvements, looking at safety, quality, cost, and schedule. This is a picture off of one of the main propulsion shafts of the ships. Again, about give you a perspective of size, those are 60 feet long and weigh about 60,000 pounds. And this is all weld cladding from here all the way to the end. So we'll refurbish a shaft and then machine that down and put new bearings on it. And these shafts require a preheat up to several hundred degrees. And the old method of doing this was with torch heaters, which is extremely inefficient. It would take several hours to get the shafts up to temperature before they could weld. And when I first was hired on, I thought, man, there's got to be a better way to do this. And I started doing research and found induction heating. So we now have an induction roller that sits on the shaft in front of the welder that preheats, and it takes about 15 minutes to get up to temperature. So that was a big process improvement for it. Whenever we implement process improvements, we have to do welder training, which is part of my workforce training. And I always refer to it as kind of a sales pitch, because I don't work directly for production, and production doesn't work for me. So whenever I come up with a new process improvement, we have to pitch that to the trades, and they have to buy in on it. And we have a lot of skilled trades who have been doing this for a really long time. And I don't know about you guys, but whenever you try to change someone else's job, they don't like it. So it's always a sales pitch. Hey, I had this new idea, and I think it's going to help you, and here's why. And my background at Ferris of spending all the time in the lab really helps me to say, here's this new technology, here's why it's going to help you, and here's how it's going to help you from a hands-on sense, because I was in the lab and really did a lot of studies, and I'm able to relate that information down to the trade level. We also do a lot of troubleshooting. Whenever you have a human factor in any kind of fabrication, you're going to have problems. So I do a lot of work in the field, looking at cracked welds. What is the science and metallurgy behind why is that weld failing? Is it a preheat? Is it interpass? Is it the wrong material? Is there a metallurgy problem going on? And once there is a problem, we have to talk to the government and explain, why is there a problem on board their ship? How are we going to fix that problem? And there's a lot of code book interpretation. The government loves code books, and it's one of my jobs to read the code books and decipher what they're really trying to say and what the requirements are to complete this weld. We have 2 mechanical engineers and 1 marine engineer that work for us. A lot of their job duties revolve around doing lifting fixtures and lifting plans. This picture here in the lower right is a stern gate off an LPD-17 class of ship. And again, to give you a size perspective, this is 60 feet wide and about 20,000 pounds. And to lift this gate is a huge safety risk. If that were to fall, it could seriously hurt someone or damage this ship. It would be pretty bad. So our mechanical engineers are constantly looking at material strengths. What weld joint design are they going to use? How thick a material? How long material? Do they need gussets on top of the side of the pad eye? If there's side loading, so there's a lot of engineering that goes behind a lifting fixture of this sorts. So we want to make sure we do it safely, but we want to make sure we do it cost effective. If we over-engineer this, if we have 15, 20 pad eyes when we could have had 8, there's a time and schedule associated with doing that extra work. So that's where the engineering science of, what is material strength, what can that material hold is really important to us. We do a lot of work with ship stability. The ships are full of service tanks, oil tanks, potable water tanks, and it turns out fluids are corrosive at times. And we're always doing some kind of structural work, doing rust repairs, doing paint work, but we have to remove the fluids out of those tanks before we can go in there and verify it's safe for man, safe for hot work. So there's stability calculations you have to do when you remove fluid from one side of the ship. You have to make sure you compensate for that fluid by either removing fuel from the other side of the ship or adding keel blocks or weights on the ship somewhere else to make sure you're not having an unstable condition. So there's calculations that go behind all those. Our mechanical engineers also do a lot of work with our diesel engines and the main propulsion shafting once the ship is out of the water. But one thing I want to stress is we are engineers, we do math, we do science, but we're also very hands-on. We get out in the field. And that was one thing, going back to my background, that I was a student that never wanted to go to college. I always thought I'd be either a welder or an electrician because I didn't want to sit behind a desk and do calculations. And when I found out about the opportunity to become a welding engineer, to have the math and science, but also go in the field and make those changes and not sit behind your desk. That's what really intrigued me and excited me to find a career of this nature. We're always looking for new technology because, as I mentioned, that this is what ship repair used to be. We're trying to bring our shipyard into the 21st century. And so we're always looking at new technology. One of the things we're currently evaluating are 3D scanners. This is a 3D scan model I pulled off the internet of some oil tankers. One way that we could implement this technology for ship repair would be for the planning and execution phase of a ship avail. Say if we were replacing a main propulsion engine off one of the ships, we could set up a 3D scanner into space and scan it and get a 3D model of what that main space looks like. And we could start planning, our rip out. Is there going to be interference? Is this light projector going to be in our way when we rip out this main engine? Do we have to cut a big access cut in the bulkhead to get the engine in and out? How are we going to plan this avail? Our mechanical engineers do a lot of work with finite element analysis software, FEA. So if I go back to this rigging plan, we have engineers who do the calculations at their desk, but those are hand calcs. FEA software is a way for us to actually analyze the 3D model and see where weak points come up. So we can model this software, add our lifting plan into it, apply the weights or whatever stress is going to be applied to that component, and we get out a visualization model that will show us colors that will show the stress points. So on this component, failure points. And you can see where that would be extremely valuable when you're lifting a 20,000-pound gate or a 60,000-pound shaft. You might want to know if there's a failure point before you lift it. Because again, someone could be seriously hurt or equipment could be seriously hurt. I don't want to call our customer and say, hey, we dropped your 60,000-pound shaft on the floor because we didn't do the engineering calculations correct. So this software is really invaluable for us. Another project that we've been working on is alignments. This is a ferro laser tracker, which at its minimum, at the base of what it is, the simplest way to explain it is it's a fancy laser that takes measurements. So I don't know if you can see these orange dots on the screen here. Those are monuments that we super glue. This is an exhaust elbow off of one of the ships. This is one of 4 exhaust elbows. And just to give you a size perspective, again, it's about 48 inches in diameter, about 15 feet tall. And we were replacing this exhaust flange on the elbow, and we wanted to make sure that the flange went back in the same configuration that it came off of. Because if the flange could be skewed on board, we wouldn't know that unless we took measurements with a laser tracker. So we got XYZ coordinates of the before condition, and then we shot it after the structural shot, put it back on to put it in the same location. And this saved about 2 weeks of ship fitter hours once the elbow went back on board the ship, because we were able to get that flange in the exact same configuration that it came off of. So that's another way that technology really helps us in ship construction or ship repair. We're also always looking at welding automation. Part of my background, I did a lot with welding robotics in college. I've done a lot with pipe welding automation, lasers, and other sources. Whenever you're going to have a human element making welds, there's going to be some potential for failure. And welding automation is a great tool to eliminate the individual effect of welding defects. And you get higher deposition rates and higher quality welds at the end of the day. So what are some of the skills that students can be working on when they're still in high school or still in college? Critical thinking skills are really important in my industry. And one thing that I've noticed is people don't always know how to break down a problem and really get to the root of the problem. And you really need to understand that there's really one root cause. There's not multiple pieces. And I think lab-based training is a great resource for this. When I was in college, our professor assigned us a senior capstone project where we had to design a small bridge over the course of our senior year. And it started day one. He briefed us, said, you're going to build a bridge. It has to be under 7 pounds. It's going to be this 410 steel alloy. And then he gave us some other design requirements, and he gave us a budget, and we had to put together a schedule, and we had to work in teams, and we had to manage that project and all the problems associated with that project through the course of a year. And that really gave us some great project management skills and great tools to really understand how to dissect problems and really get to the root cause analysis of problems. Students need to be able to apply their knowledge into the field practically. It's great to sit at your desk and make calculations and make designs and make 3D models, but if you can't take those models and apply them to the field in a practical sense, it doesn't do you a lot of good. And I cannot speak enough for lab-based training. When I left college and went to my first job in a shipyard, I was able to go into the field day one and start making changes because I had those practical applications from my lab-based training. I knew what the guys were working on because I had been doing it for 4 years. It was so important to my career path so far to have that hands-on application. Communication skills are extremely important. If I go back to this rigging plan, we had an engineer who had to design this rigging plan at his desk to make sure all the calculations were correct. But then we need to communicate what this rigging plan is to our structural shop, who's going to cut the pad eyes and do the welds and actually install them. There's an NDT plan to make sure that all the welds are set. Then they need to explain to the riggers what the actual rigging plan is. There's a communication involved with that. And you might be dealing with people who have no high school degree or someone who has a PhD. So being able to explain those problems and the technical aspect of those problems at multiple different levels is really important. So expose your students to different people, different cultures to try to get those communication skills working. And one thing that I've noticed is, with technology, it's easy to send a text, it's easy to send an instant message, but really convey the importance of one-on-one communication. Not every problem can be solved over a text. Sometimes it takes that face-to-face interaction, and that's really important in my job when you're dealing with projects of this big. So how do you get students involved? This is probably one of the best applications to get students involved. As I mentioned, I never really wanted to go to college when I was younger because I didn't know what was out there. I had no idea my job existed. It wasn't actually until my senior year of high school when I started dual enrolling in college for welding classes that I found out that I had a university 70 miles from my home that offered a degree in welding engineering. Had I known about certain societies like the American Welding Society, who they have publications, they have local society meetings, that they talk about people from the industry. They do stuff just like this where they invite people in, they give presentations, and they can explain what they do and give students an idea of what's out there. Because personally, I had no idea what was out there. I was just lucky and kind of fell into my career field, and I love it. So I can't speak enough for these societies. There's a couple there listed. They all have local sections. They have student chapters. I would highly recommend get your students involved in those chapters because there are a ton of resources out there. It's all about getting those resources to your students. I read a shocking statistic that 28% of students aren't interested in a STEM career field, but 57% of those students will lose interest by the time they graduate. And I truly believe that's all because students don't know what's out there. They don't know what industry is available to them. There might be a lot of students like me that they think they don't want to be an engineer because they don't want to sit at their desk, but they have no idea what engineering can be. So I really can't speak enough about getting your students involved and getting them into industry. Contact companies, ask if we can come do a tour, ask if people can come in your classroom and give a presentation. I think it would be very valuable for your students. That's it for me.
Thank you.